Hi, good day. How are you today? Do you want to learn new things today? Oh, I'm glad to hear that yes from you. I'm Mom Claudette, your grade 9 science teacher, and welcome to our science class. Before we start, make sure that you have with you your PPS. Pen, paper, and your self-learning modules. Are you ready? Come on, let us make fun with chemistry again. Before we proceed, do not forget to like, share, and hit the subscribe button and notification bell for updates about our latest videos. Do you still remember your lesson about calculating molar mass of a compound? Very good! Let us see if you still remember your lesson. What is the molar mass of methane? You're right! The molar mass of methane is 16.04 gram per mole. How about the molar mass of sulfur dioxide? Correct! The molar mass of sulfur dioxide is 64.07 gram per mole. I'm glad that you still remember our lesson in calculating the molar mass of a compound. I think you are now really ready for our new lesson. What do you usually do when you get sick? Yes, when we get sick, we take medicine. Medicines are chemicals or compounds used to cure, halt, or prevent disease. They ease pain or help in the diagnosis of illness. These days, medicines come from a variety of sources. When we think about taking medicines, we think of pills. But medicines can be delivered in many ways. Medicines come in forms of liquid that are swallowed, drops that are put into ears, or eyes, creams, gels, or ointments that are rubbed onto the skin. There are also inhalers, patches that are stuck to skin, which we call transdermal patches. We also have medicines in the forms of tablets. But how do we form the rightful amount of medicine that we need? In order to make the drug form its ingredients, someone has to figure out how much of each ingredient is needed to react together to make a final drug. Knowing the right amount of medicines will prevent us from having drug overdose or taking too much from a substance, which can result to abnormal breathing, loss of consciousness, and worse, may lead to death. Did you know that this concept also applies in manufacturing medicines, plastics, and even burning pieces of wood? Require the right amount of substances that will produce one. Do you know how do we measure those small entities? That's why chemists created their own counting unit called mole.
In this lesson, you will be able to relate mole concept and Avogadro's number. Also, you will be able to convert number of moles, mass, and number of atoms in a given example.
Come on, let us know more about mole. What is a mole? The mole is a fundamental unit of measurement of substances that can be defined as the number equal to the number of carbon atoms in 12.0 grams of carbon.
Mole is used to measure small entities like atoms, ions, particles, molecules, and formula unit. Mole is abbreviated as mol.
M-O-L. Just like the word dozen can stand for 12 things, the mole stands for 6.02 times 10 raised to 23 things. This is called Avogadro's number. Avogadro's number is named after the Italian scientist Amedeo Avogadro. 1 mole of something consists of 6.02 times 10 raised to 23 units of that substance. For example, 1 mole of an egg has particles equal to 6.02 times 10 raised to 23. Another example, we have 1 mole of water contains 6.02 times 10 raised to 23 water molecules. Now, I have a question.
Which has a greater number of particles? 1 mole of cotton or 1 mole of water? You're right! 1 mole of cotton and 1 mole of water have the same number of particles, which is equal to 6.02 times 10 raised to 23.
The number of moles of a substance can be calculated by various means, depending on data available, and the number of molecules. We can also calculate it the number of moles of atoms and the number of moles of particles. Not only that, we can also convert the number of moles to mass. Let's find it how. Let's have some examples. Example number 1. How many molecules are there in 4 moles of carbon dioxide? To answer this question, remember that 1 mole is equal to 6.02 times 10 raised to 23 particles. Using the dimensional analysis approach, you will be able to convert number of moles and its equivalent amount based on the number of particles. First, you have to identify the given. What is the given? Correct! We have 4.0 moles of carbon dioxide. Next, after identifying the given, we have to identify conversion factors that will help you get from your original units to your desired unit. There are 2 possible conversion factors in this example. We have 6.02 times 10 raised to 23 molecules of carbon dioxide over 1 mole of carbon dioxide. Or we have 1 mole of carbon dioxide over 6.02 times 10 raised to 23 molecules of carbon dioxide. Which conversion factor will be used to solve the given problem? You're right! Since our desired unit is molecules, we will use the conversion factor 6.02 times 10 raised to 23 molecules of carbon dioxide over 1 mole of carbon dioxide. Remember that in choosing the conversion factor to be used, you need to consider the desired units. It should be placed as numerator. Next, we have to set up your equation so that your undesired units will be cancelled out to give your desired units. So we have 4.0 moles of carbon dioxide, which is the given, times the conversion factor 6.02 times 10 raised to 23 molecules of carbon dioxide over 1 mole of carbon dioxide. Lastly, multiply through to get your final answer. 4.0 molecules of carbon dioxide multiply with 6.02 times 10 raised to 23 molecules of carbon dioxide divided by 1 mole of carbon dioxide. What is the answer? Correct! The answer is 2.41 times 10 raised to 24. Don't forget to cancel the undesired unit. A unit will be canceled out if it's appear in both the numerator and the denominator during the equation. We will cancel the undesired unit. In this case, the undesired unit that appears both the numerator and denominator is mole of carbon dioxide. What unit of measurement was left? Correct! It's molecules of carbon dioxide. Therefore, 4.0 moles of carbon dioxide is equal to 2.41 times 10 raised to 24 molecules of carbon dioxide. Do you understand? Wow! Nice to hear that. Very good. Let's try another example. Aluminum with an element symbol of Al, a metal with a high strength to weight ratio and a high resistance to corrosion, is often used for structure such as high-quality bicycle frames. Compute for the moles of atoms in a 10.0 grams sample of aluminum. In this case, we want to change from mass to moles of atoms. What is our first step to solve the problem? Very good. We need to identify the given. What is the given? Yes, we have 10.0 grams of aluminum. In this example, we need the mass of aluminum. You can get the mass of aluminum from your periodic table of elements. What is the molar mass of aluminum? Very good! The mass of 1 mole of aluminum is 26.98 grams. The sample we are considering has a mass of 10.0 grams. We calculate the number of moles of aluminum atoms in 10.0 grams by using the equivalence statement. 1 mole of aluminum is equal to 26.98 grams of aluminum. After identifying the given, what to do next? Correct! We need to construct the appropriate conversion factor. In this example, what will be our conversion factor? Very good! We will use the conversion factor 1 mole of aluminum is equal to 26.98 grams of aluminum. We can now set up the equation so that your undesired units will be cancelled out to give your desired units. 10.0 grams of aluminum times the conversion factor 1 mole of aluminum is equal to 26.98 grams of aluminum. Next, we will convert mass to number of moles. 10.0 grams of aluminum times 1 mole of aluminum divided by 26.98 grams of aluminum is equal to 0.371 mole of aluminum. Don't forget to cancel the undesired units. How many moles are there in 10.0 grams of aluminum? You're right! 10.0 grams of aluminum is equal to 0.371 mole of aluminum. Is the lesson clear to you? That's great! Let us see if you really understand our lesson. Now, it's time to show me what you've got. I have here a few questions for you to answer. Are you ready, class? Okay, let's start. Just tell me the letter of the correct answer. Question number 1. Which of the following unit is used in expressing the amount of substance in terms of number of particles? A. Liter, B. gram, C. mole, D. Celsius. Very good! The answer is letter C. Mole is the unit used in expressing the amount of substance and the number of particles. Question number 2. Avogadro's number of representative particles, 6.02 times 10 raised to 23, is equal to 1 blank. A. Liter, B. Kelvin, C. mole, D. gram. Correct! The answer is letter C. 6.02 times 10 raised to 23 particles is equal to 1 mole. Question number 3. How many moles are there in 40 grams of calcium if its molar mass is 40 grams? A. 1 mole, B. 2 moles, C. 4 moles, or D. 5 moles? Correct! The answer is letter A. 40 grams of calcium is equal to 1 mole of calcium. Question number 4. How many moles are there in 6.02 times 10 raised to 23 particles of sodium chloride? A. 2 moles, B. 1 mole, C. 2.5 moles, or D. 3 moles? Correct! The answer is letter B. You're doing great. 6.02 times 10 raised to 23 particles of sodium chloride is equal to 1 mole. Now, let's answer the last question. Question number 5. What is the mass of 2 moles of chlorine? Remember that the molar mass of chlorine is equal to 35 gram per mole. A. 35 gram, B. 105 gram, C. 14.5 gram, or D. 70 grams? Very good! The answer is letter D. 2 moles of chlorine is equal to 70 grams of chlorine. Wow! Amazing! You got a perfect score. It seems that you are ready to answer your learning task on your self-learning module. But before that, let's have first the important things that you must remember. First, the mole is a fundamental unit of measurement of substances and can be defined as the number equal to the number of carbon atoms in 12.0 grams of carbon. Next, remember that Avogadro's number, 6.02 times 10 raised to 23, is equal to 1 mole of things. We should also remember that in solving mole problems using dimensional approach, you need to follow the steps. First, identify the given. Second, identify the conversion factors that will help you get from your original units to your desired unit. Third, set up your equation so that your undesired units will be cancelled out to give your desired unit. And lastly, multiply through to get your final answer. With that, I hope you learned something new today. See you next time!